Hello, I'm Ray. In this video, I would like to show you how to do data preprocessing with Neat to convert raw data into a format that's ready for Bragg fitting. The preprocessing involves a few steps done in sequence. The first step is summation. If your experiment was split into multiple runs, you can use this step to combine them into one dataset. This helps improve the statistical quality of the data. If you only have a single run, then you can skip this step. Next is cleaning. This step replaces abnormal pixels with the average of the surrounding ones, which helps clean up the dataset. Then we have overlap correction. This step adjusts for the overlap issues due to the detector. I won't go into detail here, but you can find more information about it in the relevant literature. The final step is normalization. Here, the sample dataset is normalized using an OpenBeam dataset. And after this, the data is ready for Bragg fitting. To make sure the processing works as expected, there are a few important requirements for your files and folder structure. First, the image files need to follow a specific naming format. Each image should have a 5-digit suffix at the end of its file name, and these numbers should be in sequence. Second, 2 essential text files must be placed in the same folder as the images, one called spectra.txt and the other called shuttercount.txt. Having the images properly named and these 2 text files in place ensure that the processing runs smoothly and without errors. All of these processing steps support batch processing, which means if you have multiple datasets, they can all be processed in one go, saving you time and effort. To make sure the batch processing works correctly, your datasets need to be organized in a specific folder structure, which will be explained later in this video. Now let's start with the summation step. Neat supports batch processing, which is especially useful if you have multiple samples and each sample has multiple runs that need to be summed. For batch summation, the datasets need to be organized in a 3-level structure. The parent folder contains multiple subfolders for each sample, and inside each subfolder, there should be the individual runs for that sample. If you are only working with one sample, just select the folder that contains all the runs for that sample. So first, we click Add Data button to select the parent folder that contains multiple samples. Next, choose a folder where the summed datasets will be saved. Then provide a base name for that output's files. Once everything is set, click to start the summation. You will see detailed information about the summation process displayed in the message window. After the summation is complete, you can check whether the summed datasets have been saved correctly in the folder you selected. The second step is cleaning. Just like with summation, Neat supports batch cleaning. For batch cleaning, select the parent folder that contains the summed subfolders. Then choose an output folder and set a base name for the cleaned files. Finally, click Clean to start the process. Then is overlap correction. Again, select the parent folder that contains the cleaned subfolders. Then choose an output folder and then set a base name for the corrected files. Finally, click Correct to start overlap correction. Once both the sample datasets and the OpenBeam datasets have been corrected, we are ready to perform normalization. For batch normalization, we start by selecting the parent folder that contains multiple sample datasets. Then, we select one OpenBeam dataset to be used for all of them. This ensures that every sample dataset is normalized using the same reference. In many cases, the OpenBeam can be noisy, adding noise to the normalized dataset. A practical method to tackle this is to smooth the OpenBeam before normalization. Here are two parameters for us to control smoothing of the OpenBeam dataset. So, the first parameter defines the number of pixels used for spatial binning. If you set it to n, the OpenBeam intensities will be averaged over a region of 2m plus 1 by 2m plus 1 pixels. And this average is applied to the central pixel. The second parameter controls the temporal smoothing, which means how many frames are averaged. If the value is m, then 2m plus 1 frames will be averaged, and the result is assigned to the central frame. Once these parameters are set, you can simply click to start the normalization process. Now that the dataset has been normalized, it is ready for Bragg fitting. But before we proceed, there is an optional step that can help improve the quality of the dataset. In this step, we apply a mask to filter out areas outside the sample region, leaving only the region of interest for subsequent Bragg fitting. The mask can be created using external software, such as ImageJ, and should be saved in .fits format. To perform the filtering, first select the folder containing the dataset you want to filter. Then select the mask file and choose an output folder and set a base name for the filtered dataset. Finally, start the filtering process. This step helps remove unwanted areas and focuses the fitting on just the region of interest.